Do you think rivers are just water flowing from point A to point B? How about a river that people reversed and now protect from the consequences of that decision with electric fences right in the water? Or a stream with no fish, no frogs, not a single familiar living creature? Yet NASA studies it as a rehearsal for searching for life on Mars. And finally, a river that boils every living thing alive, right in the middle of tropical jungles, far from any volcanoes, and it has existed for 1 million years. Today we'll look at 5 water bodies that break all the rules, and we'll start with the most harmless, though harmless is a strong word. There are about 165 million rivers on the planet, most of which we've long tamed, straightened, dammed, filled with barges and yachts. We're used to thinking water obeys us, flows where we tell it, runs in the direction we dictate. But some rivers refuse to fit into this familiar picture of the world. One of them kills with heat, others with acid, and the third flows where rivers have no place by definition. The fifth item on our list will prove that humans can change nature itself. The fourth will show that nature can respond. And the first leaves you with no arguments against the fact that the Earth is a living machine that barely tolerates us. The fifth spot is occupied by a story about a river. It's a river that humans literally turned backwards. If you find yourself on the Chicago Riverwalk and look at the water, you'll see something absurd. On the bank stands a modest sign, "Here the river flows backwards." Not a metaphor or artistic exaggeration. The Chicago River really does flow backwards and has for 125 years. It's the only major river in the world whose direction was intentionally reversed 180 degrees by human efforts. And before 1900, everything was different. The Chicago River used to flow into Lake Michigan, one of the largest freshwater reservoirs on Earth, from which the entire city drank water. The problem was that into this same river, residents dumped everything: sewage, industrial waste, blood, and offal from Chicago's slaughterhouses. Chicago was then the world capital of the meat industry. Several million head of livestock were slaughtered here annually, and the waste from these operations went straight into the river. The river carried it to the lake, and the lake supplied water to the taps. The result was expected. In 1885, a terrible epidemic of typhoid and cholera killed about 90,000 people, roughly 12% of the city's population. 1 in 8 Chicago residents died. The authorities realized they couldn't continue like this. Building treatment plants with the technology of the time was impossible. And then someone proposed a solution so audacious it took engineers' breath away. What if we just reverse the river? For this, the Chicago Sanitary and Ship Canal was dug 40 kilometers of artificial channel through the watershed between the Great Lakes Basin and the Mississippi Basin. 8 years of work, 1,000 workers, and 1 million cubic meters of excavated rock. On the 21st of January 1900, the locks were opened. The water that for millennia had flowed east into Lake Michigan turned and flowed west toward the Illinois River and then to the Mississippi. The residents of Chicago won, but the residents of Street Louis, located downstream, did not share that enthusiasm. Street Louis immediately filed a lawsuit claiming that Chicago was essentially exporting its sewage into their drinking water. The case went to the U.S. Supreme Court. In 1906, the court ruled in favor of Chicago, deciding that a direct link between Chicago's sewage and disease outbreaks in Street Louis was not proven. Formally, it was a victory. In essence, it was a precedent. One city literally threw its problem to its neighbor, and the law approved it, but the reckoning came later. The canal connecting 2 independent water basins created a passage that never existed in nature. And through this passage, biological species began to migrate back and forth, destroying ecosystems. The main threat today is the Asian carp, a voracious, rapidly reproducing fish imported in the 1970s from Asia to clean aquaculture ponds. It escaped into the wild and is devastating the Mississippi River. Now it is moving north, straight toward the Great Lakes. The fishing industry in this region is worth $7 billion a year. If the carp gets into the lakes, that number will drop to 0. To combat the fish, electric barriers have been installed in the canal. Literally an electric fence underwater, operating around the clock. It sounds like a scene from science fiction, but it's a reality from 1900 catching up with us in the 21st century. Every human intervention in nature has unforeseeable consequences, and generations have to pay for them. The fourth spot is taken by a river that kills not with heat or electricity, but with color. Picture this, a Spanish landscape, the province of Huelva in the southwest of the country, and suddenly a river that looks as if someone poured several tons of scarlet paint into the landscape. The water is a deep, dark red, sometimes orange. The banks are crusted with mineral deposits in yellow, purple, almost black. Not a single fisherman on the shore, not a single heron by the water-dead silence. This is the Rio Tinto, the Red River. Its acidity is pH 2, about the same as stomach acid. Heavy metals are dissolved in the water: iron, copper, zinc, arsenic, cadmium. For most forms of life that we consider normal, this water is instant death. No fish, no mollusks, no amphibians live here. The river is biologically dead by any normal standards. The red color of the water comes from the high concentration of dissolved iron, oxidized by acid. The acid itself comes from sulfide ores, which are incredibly abundant in this region. When sulfide minerals, pyrite, chalcopyrite, and other compounds of sulfur and metals come into contact with water and oxygen, a chemical reaction begins releasing sulfuric acid. This process is called acid mine drainage. In nature, it proceeds slowly, but humans have accelerated it immensely. This area has been mined continuously for 5,000 years. The Phoenicians mined silver here, the Romans mined copper and gold. In the 19th century, British and German companies turned the region into a giant open-pit mine, extracting 1 million tons of ore. Each new layer of exposed sulfide rock accelerated the chemical reaction. 5 millennia of continuous mining turned an ordinary river into an acid stream. People killed it slowly, generation after generation, and no one noticed because each generation saw only its own small piece of the process. Irony of fate. One of the world's largest mining corporations still bears the name of this river, Rio Tinto. The company named after the murdered river continues to extract resources on other continents, creating new Rio Tintos in other countries. The cycle continues. But here's what's astonishing, and that is precisely why NASA is studying this river so carefully. In this water, which should be completely dead, there is still life. Not fish or frogs, but extremophilic bacteria and algae that not only survive in the acidic environment but thrive in it. They feed on dissolved metals, use sulfuric acid as an energy source, and cover the riverbed with dense mats of red, green, and purple. Life that eats acid. Life for which a mouse is food. That's why astrobiologists look at Rio Tinto as the closest earthly analog to Mars conditions. The red planet is covered in iron oxides, hence its color. Beneath the surface, there may be acidic groundwater saturated with metals. If life exists on Mars, it might look exactly like those bacteria from the Spanish acid river. NASA has been funding research at Rio Tinto for over 20 years, testing instruments there that will someday be sent to another planet to search for what has already been found here. A dying river as a proving ground for searching for life in the universe, it's either very encouraging or very frightening. It depends on how you look at it. The third spot is occupied by an object that disrupts the very concept of where a river can exist. In 2010, a group of British scientists lowered it to the bottom of the Black Sea. A new generation echo sounder can distinguish layers of water of different densities. When the data appeared on the screen, the researchers exchanged glances at the monitor. A riverbed was clearly revealed with winding banks, floodplain areas, rapids, and even what geologists call oxbows, dead loops, cut off from the main current. It was a full-fledged river, a real river at the bottom of the sea at a depth of 35 meters. The picture looks like this. You are swimming in seawater. You descend a little deeper, and suddenly you see beneath you the surface of another water, darker, heavier, with a clearly visible current. That current carries silt and sediment along a winding bed, with banks up to a kilometer wide. Divers who have descended to this river describe the same feeling. You lower your hand below the boundary between the layers, and the current pulls it to the side. The sensation is absolutely real. Water within water, a river in the sea. The secret lies in the difference in density. The water of the underwater river is significantly saltier, and therefore heavier than the surrounding seawater. It flows in from the Mediterranean Sea through the Bosphorus Strait. The Mediterranean water, being saltier and denser, penetrates the Black Sea and sinks to the bottom. It moves along an established channel, obeying the same physical laws as ordinary rivers on land. The difference in density between the river and seawater is sufficient to form clear banks, turbulent eddies, and a directed current. If this underwater river were flowing on land, it would be the sixth largest river in Europe by water volume, larger than the Rhine, larger than the Seine, larger than most rivers you heard about in school geography lessons. For geologists, this discovery turned the understanding of seafloor formation upside down. It turned out that submarine canyons and sedimentary basins are created by the same processes as river valleys on land, by flowing water that erodes banks and transports sediment. Only this water flows under other water. The Black Sea underwater river plays a critical role in the sea's ecosystem. It carries nutrients along the bottom, enriches the bottom layers with oxygen, and creates unique conditions for organisms living at the boundary of two waters. Underwater rivers are not a unique phenomenon. They have been discovered in the Gulf of Mexico, off the coast of Australia, in the Caribbean Sea. But the Black Sea one is the largest known and best studied. It took us several thousand years living next to the Black Sea to discover that another river flows within it. What else hides beneath the surface of familiar things we consider long studied? The second spot, the silver of our top, is occupied by a lake in Tanzania that turns all living things into stone. Formerly it is a lake, but it is fed by rivers flowing from volcanic regions of East Africa. And these very rivers are among the most extreme water bodies on the planet. The water in Lake Natron is alkaline, with a pH from 10 to 11.5, comparable to an ammonia solution. The temperature in some areas reaches 60 degrees. In this water, natron is dissolved sodium carbonate, the very mineral that ancient Egyptians used to mummify the bodies of pharaohs. Imagine such a scene. A flock of migratory birds flies over East Africa. Below, the water surface gleams smooth, pinkish. The beautiful birds descend, land on the water. But they don't know, how could they? The alkali immediately begins to corrode feathers and skin. Natron saturates the tissues. After a few hours or days, the bodies calcify, become impregnated with minerals to a stone-like state. Wind and waves wash them ashore, where they can persist for years. Birds with outstretched wings, frozen in flight poses, covered with a white mineral incrustation. In 2013, British photographer Nick Brandt found dozens of such bodies on the shores of Natron. He arranged them in natural poses and photographed them. The images went viral around the world and became one of the most shocking nature photographs. Eagles with spread wings on branches, swallows in flight, bats stuck to the reeds all white, all motionless. All forever. The mechanism is simple and ruthless. Birds, especially migratory flocks, mistake the shiny surface of natron for a normal body of water. One landing, and the system works flawlessly. The alkaline water burns skin in minutes, but the Maasai, who have lived on the lake shores for generations, know its nature well. They use natron, which can be collected on dried sections of the shore, for treating hides and as a mineral seasoning. But people do not enter the water itself. Those who attempted to wade across the shallow lake received chemical burns on their legs, which took weeks to heal. And now a twist that nature prepared specifically for those who think they understand its logic. Lake Natron, which kills almost all living things, is the world's only breeding site for the lesser flamingo in East Africa. About 2.5 million birds nest on salty islets in the middle of the lake. Each season, the alkaline water that burns and mummifies all others creates perfect protection for the flamingos. No land predator can physically reach the nests because the water would immediately burn its feet. Flamingo legs are covered with tough scales, and special glands filter salt and alkali. The Lake of Death is simultaneously a home for 1 million birds. From the air, natron looks like an abstract painting. It changes color from bright red to pink and creamy white, depending on the concentration of algae and water temperature. Pilots of small aircraft call it one of the most beautiful sights in Africa. Beauty and death in a single frame. The Tanzanian government has several times considered projects to build soda ash extraction plants right on the shore. Ecologists warn, industrial activity will destroy the fragile balance and wipe out the largest flamingo colony from the face of the earth. The projects are frozen for now. For now, and finally, the first place, the absolute leader of our list, a river that legends have told for centuries, which scientists considered a myth, and which turned out to be real, boiling, and completely inexplicable. In the heart of the Peruvian jungle, several days' walk from the nearest road, there is a place that local tribes call Shanay-Timpishka. In the Ashaninka language, this means heated by the sun's heat, but the sun has nothing to do with it. A 6-kilometer stretch of this river literally boils, with surface water temperatures between 70 and 100 degrees Celsius. Steam billows over the water year-round, and the stones on the bottom are covered with thermophilic bacteria. Any living creature that accidentally falls into the river dies within seconds. Local people describe this without excessive emotion because they have seen it many times. Small animals, lizards, frogs, snakes sometimes slip and fall into the water. The proteins in the eyes are the first to coagulate. The animal goes blind before it can understand what is happening. Then the skin, then the muscles. Within seconds, all that remains of the creature is a shapeless mass carried away by the current. This is not a metaphor. It's a description of the chemical process that happens to protein at temperatures above 70 degrees. Legends about this river have been told for hundreds of years, but scientists didn't take them seriously. A boiling river in the jungle far from volcanoes contradicts basic geological principles. Hot springs exist only where there is volcanic activity. The nearest volcano to Shanay-Timpishka is 700 kilometers away. That's impossible, scientists said. In 2011, Peruvian geophysicist Andres Ruzo, who grew up on his grandfather's stories about this river, decided to check the legend personally. He fought through the jungle, found the river, and lowered a thermometer into it. 100 degrees, he didn't believe it. Checked again, 100 degrees. The steam burned his face. The ground around was hot to the touch. The legend was true. Ruzo spent several years studying the phenomenon, and his conclusion surprised even the skeptics. The water in Shanay-Timpishka is ordinary rainwater. Rain that fell in the Andes hundreds of kilometers away seeps deep into the Earth's crust, several kilometers down. There, where the rock temperature exceeds 200 degrees, the water is heated. Then it rises back to the surface through a system of deep geological faults and emerges as a boiling river. The water boiling in Shanay-Timpishka today may have fallen as rain decades ago, a giant natural kettle with a multi-year heating cycle. Ruzo installed a network of temperature sensors along the river, and it turned out that the temperature fluctuates with the seasons. In the dry season, the central section of the river reaches 100 degrees. In the rainy season, cool water partially dilutes the boiling water, dropping the temperature to 60-70, but even in the cold period, the water is guaranteed to cause third-degree burns within seconds. For the local tribes, Shanay-Timpishka is a sacred place. Shamans use its steam for rituals and the water for preparing medicinal decoctions. They believe that a giant serpent spirit lives in the depths of the river, guarding the jungle. Despite his scientific skepticism, Ruzo admits, standing on the bank in a cloud of boiling steam, listening to the roar of the water, it's hard not to feel something otherworldly. The boundary between science and myth literally dissolves in the hot mist here. The discovery of Shanay-Timpishka called into question existing geothermal models. It was believed that hot springs of this scale without a nearby volcano were impossible. It turned out that a deep fault is enough. This means that similar boiling rivers could theoretically exist anywhere on the planet. Where there are deep faults and sufficient rainfall, how many such rivers are hidden in the impenetrable jungles of the Amazon, in the mountains of Central Africa, in the wilds of Borneo? We simply don't know. The map of the world's boiling rivers is, in all likelihood, still incomplete. 5 rivers, 5 ways to rewrite what you thought about Chicago water. Humans reversed a river's flow and now fight the consequences of that decision with electric barriers. Rio Tinto. 5,000 years of human mining created an acidic stream where organisms from Mars live. The underwater river of the Black Sea is a full-fledged watercourse with banks and a current. Lake Natron, lying 35 meters below sea level, mummifies animals with sodium carbonate and at the same time is the only maternity ward for 2.5 million flamingos. Shanay-Timpishka is a boiling river in the jungle without volcanoes, whose water is heated deep in the Earth's crust and rises through faults for several million years. Each of these rivers is a reminder that we live on a planet we barely have time to study. Satellites have photographed every square meter of the surface. We think we know everything. But you just need to dive 30 meters deep, or break through the Peruvian jungle, or simply measure the water temperature in a river that has been the subject of legends for centuries, and the Earth becomes unfamiliar again.